Next up, for the Tetris game, we are going to implement basic collisions. Which means, if a piece collides with the left or right side of the wall, we're going to stop the movement, and if it collides with the floor, it's going to stay on that floor. That way pieces don't disappear anymore. Once we have that, we can also start working on making pieces collide with each other. But step by step, and let's jump right in. Here we are back in the code editor, and once again, I want to work inside of game.py. For now, the basic thing that I want to work on is if this is the game field and a piece moves too far to the left or too far to the right, we want to constrain it to either the right side or the left side. To illustrate the issue, if I run main.py again, the player could simply move to the right outside of the field or do the same with the left side. So that we have to work on. The majority of the logic is going to happen inside of the Tetramino class. In there, I want to create a section for the collisions. And I guess while we are here, we can also add sections for the movement. For the collisions, there are going to be two methods that are really important. The first one is going to be, I call this one next move horizontal collide. This one needs to know self, then the blocks we are going to move, and then the amount we want to move by. And let me explain the logic first of all. If we once again look at the field, and we have a piece all the way on the left right now, and we want to decide, can this piece move further to the left or not? For that, we have to check where it would be on that next movement. In this case, if this is below 0, it should not be possible. The basic logic is going to be, we are going to create an imaginary Tetris shape where we are going to move all of the pieces in the desired direction. That is very hard to see, but we are creating an imaginary Tetris shape that would be in the new position. And if then any of these shapes is going outside of the field, we are going to block the movement. For all of that, let's create a collision list. This we are getting with list comprehension. Basically, all I want to do, we can start with block for block in self.blocks. That way, we are simply copying everything inside of the blocks. However, for each individual block, we want to do a horizontal collide. This doesn't exist right now, but we can create it. And for that, I want to add one argument, which is going to be an integer of the block position, so block pos.x. For this method, we are only checking the horizontal movement. And to that position, we are going to add the amount. The amount here could be 1 or -1, meaning we are going left or right. With all of that, we are creating an imaginary new Tetramino where we can check if it's too far left or too far right. Although for all of that, we have to create the horizontal collide method. This is going to happen inside of the block. In there, I want to create a horizontal collide. It will need self and it will need an x position. All I really want to do in there is if not 0 is smaller or equal than x, and this one has to be smaller than the columns. Basically what this is going to mean, and let me minimize everything that we don't need so I can put everything in one view. That should work like this. Inside of the Tetramino, the collision list is going to look at every single block and then call the horizontal collide with a new x position. And on this new x position, we can check if we are too far left, so smaller than 0, or if we are greater than the amount of columns. If this condition triggers, I want to return true. That way, if there's any piece too far left or right, we are going to have a true value inside of this list. And we don't actually have to care about specific positions. We can keep that inside of the blocks. All we care about if there's a collision or not. And that we can then use. Inside of next move horizontal collide, we can return true, but only if there is any true value inside of the collision list. If that is not the case, so else, I want to return false. This is then going to check if there's any true value inside of the list, this entire function, or rather method, is going to return true. However, if there isn't, it is going to return false, which is super handy because that we can use inside of move horizontal. Because in there, I want to add an if statement. I only want to allow horizontal movement if self.nextMoveHorizontal collide with self.blocks along with the amount we are getting from the parameters. Only if that is not the case, then we want to allow horizontal movement. And with that, I can run all of that. And now I cannot go further to the right anymore. The same is going to apply to the left side, and this is looking pretty good. Cool, I'm very happy with that. Although we still get the vertical collision. And that one could be your exercise. I want you guys to implement the vertical collision mechanic so that pieces stop moving once they reach the bottom. Pause the video now and try to figure this one out. Back in the code, we want to do pretty much the same thing we have done for this method except for the vertical axis. Which means define next move vertical collide. This one is going to need self, blocks, and the amount. Pretty much the exact same thing that we have done for the horizontal part. Inside of there, we want to create a collision list once again, which we create with list comprehension. I want to do block for block in self.blocks. And then for each block, I want to call a vertical collide method. This one needs to have one integer with block.pos.y plus the amount. The amount, once again, we are getting from the parameter of the next move vertical method. Once we have that, we can work inside of the block. In there, we can have a vertical collide with self and a y position. All I want to check in there is if y is greater or equal than the amount of rows that we have. If that is the case, I want to return true. That is all we need from the blocks. So next up, this list is going to contain a true value if any block inside of the tetromino is going to be below the rows, which means I want to return true if any value inside of the collision list is true. If that is not the case, so else, it should be false. And then finally, inside of move down, I only want to move a block down if we don't have a self.nextMoveVerticalCollide with self.blocks. And the amount for this one is simply going to be 1. Then don't forget to indent the for loop. And now, inside of main.py, we have to wait for a second. And there we go. Now the piece is not going to go any further down. Although we can still move it left and right, which looks a bit funny, but at the very least, we have a really good start. So with that, we have some basic collisions. Next up, we can work on the collision between pieces.